we get to example 1, and in the examples we did on the colored sheet, we had to learn 4 new graphs and what they look like. Sometimes in the textbook or on quizzes or tests, you get a random graph, which you don't know the equation of, and you're still asked to do translations left, right, up, and down. So they gave us this random graph of g of x, and we want to sketch the image graph. So there's some new language that's happening here. We call the graph that we graph after the first one the image graph. And then we want to write the graph, and this one comes up quite a bit. We're going to talk about what does it mean when they say write the equation of the image graph in terms of the function g. State the domain and range of each function. So here we have our g of x graph, and we are going to do part A in blue. We are going to translate this 4 units to the left. I'm going to take this dot, 1, 2, 3, 4, move it 4 to the left. Take this one, 1, 2, 3, 4, move it 4 to the left, 4 to the left, and 1, 2, 3, 4, 4 to the left. Make 4 new dots. And I don't know when the last time you did connect the dots in school, but that was fun. We just draw the line in between the dots, and we get our new graph. Now, what's happened is we have moved it left and right. And what we've discovered already is anytime you move something left or right, that happens inside the function. In this case, if the regular function was g of x, then the blue graph is g of x. And to move something 4 to the left, do we write +4 or minus? I mean 4 to the left. We would write +4 to move it 4 to the left. And this is in terms of the function g. So when you see in terms of something, that means that on the right-hand side of your final equation, we need to have g there somewhere. We need to have the function g on the right-hand side. We write it as x plus 4, because this would be how to show that the graph of g has been moved 4 to the left. In our original colored papers, we had actual equations. And in this case, we don't have the actual equation, we have function notation for the equation. So since we don't know what the actual equation is for the red graph, we just say it's some function g of x. We don't know what it actually is. And that function g of x got moved 4 to the left. We can show anything moved 4 to the left by changing something inside the function. So it would be g of x plus 4. Next, we can write the domain for the blue one. Domain are your x values. 2 ways that we could write our domain. One is called set notation, one is interval notation. I introduced both a little bit on the colored sheets that we did. I'll introduce them again. We'll do both of them at the beginning for a bit, and then after that we'll sort of alternate from one to the other so that you keep your skills up with both of them. So if you are writing in set notation says, and both notations say, do you know what the smallest value is of this graph? Yes. The smallest x value, can you see the blue graph is -5? Can you see that the biggest x value is 2? It goes from -5 to 2. We write that by saying x is between -5 and 2. And this is called set notation. We can also write from -5 to 2 in interval notation. In interval notation, we write the -5 and 2. If the value is included, we use square brackets. and that is interval notation. Same thing for the range. We ask ourselves, is there a smallest y value? So coming from the bottom up, yes, 2 is the smallest y value. And is there a biggest y value? We go up to 5. So we can say the range that y is between 2 and 5, or in interval notation, we go from 2 to 5 with square brackets. So again, here, I did A in blue, my graph is in blue, my work is in blue. That way I can, because of color coding, connect everything to how it is. I can do B, I'm going to do B in a different color, do B in green, translation of 1 unit up, so I'm going to take my red graph and draw everything 1 unit up. Its equation for B, moving things up and down happens outside our function. And whereas things are opposite for x, everything that's with x is opposite of what you think. With the y value outside the function, it's exactly what you think. If you want to move up 1, you go +1. You want to move down 1, you go -1. So this would be the equation in terms of the function g. And domain, what's my smallest x value? -1. What's my biggest x value? 6. So that would be in set notation. That would be in interval notation. And the range, my smallest y value is 3. And my largest y value is 6. So we could write it that way. One thing that I'm going to model right at the beginning of the year a fair bit is once we're done a question in math, you reread the question again just to make sure you've done everything they've asked for. Some of the textbook questions are notorious for asking multiple things. So here's the graph. Sketch the image graph. We've done the sketch. Okay, write the equation in terms of the function g. Yes, we did that. State the domain and range of each function. Yes, we've done that as well. So sometimes you might see sketch and your brain goes, oh, I know how to do that. And you go right away and sketch the graph. And then once you're done, your brain says, good job, you're done. And sometimes we move on to the next question because our brain was like, you did what they asked for and you did a good job. But you didn't read the whole question, right? You saw a sketch and you were so excited that you knew how to do something, you did it right away, and you got that done and you felt like moving on, okay? Take the time, especially on quizzes and tests, to reread a question, make sure that you've answered everything that has been asked for. The next thing we're going to find with this textbook is after I do an example, I am going to give you a list of questions from the homework that you are now able to do. My suggestion is above example 1, I'm going to write down 4, 5, 6, and 7. So I'll get you to write 4, 5, 6, and 7 above example 1. And then now turn to the homework and circle question 4, circle question 5, circle question 6, and circle question 7. It starts on page 169. So what this does is, yeah. What this does is that we will not have time in class to do the questions, unfortunately. It used to be that we had time to start them. We usually don't have time in class to do them. Then when you get home tonight, you're going to turn to lesson 1, do a quick review of the examples that we did. Then when you turn to your homework, you see the ones that are circled, and you're going to say, okay, these are the ones that I need to do for practice. Okay? These are suggestions. If you look at question 4 and you read it and go, I know how to do that, Maybe you want to skip it. Because I don't want you to waste time doing stuff you feel really confident in. Right? Maybe you want to leave it for later. Maybe 2 days from now you want to look back at that question and you might, ooh, do I still know how to do this? Maybe I should try it. And then when you try it, you can check your answers. Now the nice thing also about the textbook is the answers are at the end of the homework, not at the end of the book. So if you turn to page, like the homework starts on 469, then you'll notice that on page 176, that is where all the answers are. So you don't have to turn all the way to the back to find the answers, which is kind of nice. So you should be doing a question. If you're unsure, checking your answers often, because we don't want to necessarily do the wrong things 10 times in a row and get really good at it and develop a habit. So checking answers as you go is important.